Welcome to the product presentation on liquid flow controller. The name of our product is LFC. Our product has a wide application in the process control industries where flow control is one of the main or the invariably used function. Normally in such cases, a pressure control valve is used in which the energy consumed by the pump is of not a concern actually. In our product, the energy consumed by the pump, or in other words, the liquid flow, is made as a function of power. In the sense, lesser the flow, lesser the power consumed by the pump. So hence, our product is an energy conservation product. In a process control industry, invariably a pressure control valve is used where though the flow varies, the power consumed by the pump doesn't varies. Our product uses an intelligent controller using Texas Instruments microcontroller TMS320F28027. You are watching the power circuit arrangement of our flow controller. It consists of an inverter fed by a three-phase rectifier. The input of the rectifier is a three-phase supply, which is the inverter drives an induction motor-based pump. The inverter is controlled by a power control unit, which we refer to as an intelligent control unit. Now you are watching the functional block diagram, which you will be shortly watching, the functional block diagram of the power control unit. The heart of the control unit is the C2000 launch pad. It receives the signals from the sensors and generates PWM signals, appropriate PWM signals to control the inverter. There is a driver circuit which interfaces the microcontroller and inverter. We are going to demonstrate our product using a three-phase induction motor pump. And now you are watching our power control unit, which consists of a C2000 launch pad. There is a power supply and level shifter circuit, which interfaces a 3.3 volt PWM pulses to the 15 volt gate input of your IGBTs. Now you are watching the inverter and the pump. The inlet of the pump is fed to the sump available in our college. The outlet is left open so that the viewer can visually observe the water flow. Now we are watching the inverter, that is a semicron based inverter, and we have kept some Agilent power oscilloscopes and the Fluke power quality analyzer for performance analysis. Now we are watching the sequence of operation. The input to the rectifier is turned on, output from inverter is turned on. There is an optional manual control apart from the automatic control. There is an optional manual control to vary the flow. Basically, it varies the frequency and voltage of the induction motor. Now we can see as the left you are watching the voltage of the V by F controller. As the V by F control varies, the voltage fed from the inverter to the motor varies. That is what you are watching right now. Now you can see the motor is pumping water from the sump and simply letting it outside. This is a setup. Once again, the sequence of operation. Once again, the sequence of operation. You can see the flow is slowly increasing further. Now the flow is almost 100%. Actually, now what we are going to demonstrate is, actually we have a outlet valve in the outlet. We are going to operate that valve and show the power consumed by the motor. That is a manual control without using any electrical control. Then we are going to show the water flow control and also show the power consumed by the motor. Let us see what's the differences. Now you are seeing there is a valve, blue color valve, which is fully open now. Now the flow is slowly increasing. The flow is fully increasing. There is a power quality analyzer which will show the power consumed by the pump, the induction motor based pump. Now the flow is 100%. Please watch, the flow is 100%. Now the power consumed by the motor is, let's wait for the power quality analyzer. Now it is on the screen. Please watch, the power consumed by the motor is 3.61 kilowatt, 3.56 to 3.61 kilowatt. Now the valve is operated in order to reduce the flow. The power is also reducing from 3.5 to something around 2.6. Look at it. Now the flow is reduced by manually using a valve, control valve, not using our flow control. The power has come down from 3.5 to 2.5. A 1 kilowatt reduction, 3.5 kilowatt to 2.5 kilowatt. Look at it again. The valve is fully made open. The flow is 100% now. When the flow is 100%, the power consumed is 3.6 kilowatt, 3.6 kilowatt, 5 kilowatt. Now let us see what is the power consumed without operating the valve by using our liquid flow controller. Now the valve is open, the flow is 100%. Once again the power is 3.59 kilowatt. Valve remains open, but the flow is reduced by our liquid flow controller. See, the flow is reduced. Now look at the power, which has come down to 280 watts, 0.29 kilowatt or 280 watts, which is once again increased to 3.59 kilowatt. Look at it, flow 100%, power is 3.5 kilowatt, valve is fully open, flow is reduced, it is simply consuming 210 watts. See, flow is reduced, valve is fully open. Look at the power, it is 290 watts, which was virtually, it is, you can observe the power has reduced from 2.5 kilowatt to just 290 watts, which is a huge reduction in power energy, which has a great application in the industry. What you are watching now is the induction motor voltage as well as the current. Though the voltage yellow color, which is pulsed, the current is absolutely sinusoidal and hence no problem associated with harmonics. Our intelligent control unit controls the inverter in such a way that there is no any